Hello, everyone. My name is Nouman Afzal. I'm a third-year PhD student at the University of Illinois, Urbana-Champaign. I'm excited to share my research with you today. That is in collaboration with University of Kansas, Kansas Geological Survey, and Michigan State University, and is funded by the U.S. Department of Agriculture. Nowadays, we see an increase in the development and use of hydrologic models to assess the response of water resource to climate change, water use, and other stresses, and subsequently to inform policy. However, they're not always adopted by the end users. This disconnect may be partly due to different values related to nature and the scientific process. Values are enduring beliefs that shape behavior, risk perception, and normative attitude, and are critical to understand for understanding the mechanisms behind many water management decisions. Historically, hydrologic models were built by engineers or scientists without acknowledging their own values or eliciting input from end users regarding how they were interpreted or used. As a result, some use were prioritized over others in water decisions. A deeper understanding of how model developers and users consider different values in the development and use of hydrologic models can inform model development that are not only more used and useful, but potentially support a great diversity of management decisions. In this study, we focus on a total of four nature values and five epistemic values. Epistemic values are principles or standards followed by scientists as well as scientists to guide their pursuit of knowledge. On the other hand, nature values affect how humans relate to and understand nature, from provision of resources to a sense of living with nature. We focused on nature values because water management decisions affect broader ecosystems and the services they provide. We used a values-informed mental models approach to understand how hydrologic models are perceived, understood, and used by agricultural producers, water managers, and model developers. Mental models are a cognitive representation of the external world that help people understand, learn, reason, predict, and ultimately make decisions. For the study area, we focused on aqueous beds groundwater management district 2, and we conducted semi-structured interviews with agricultural producers, water managers, and model developers from the region. Our results showed that of the four nature values, all except oneness was expressed by participants. Similarly, all five epistemic values were mentioned at least once. Model developers showed significantly more concern for accuracy, methodological soundness, and testability than agricultural producers and water managers. Similarly, water managers showed most concern for accuracy, followed by usability and stewardship, while agricultural producers showed most concern for livelihood values. We also identified a number of water decisions that we categorized into five decision types. For instance, when talking about making regulatory decisions, water managers said that most of the time they extract data from the model, such as recharge rates, pumping rates, or distance from a particular well, to conduct their own analysis and determine if they could allow the development of a new well or a change in the location or type of water use. Agricultural producers who were board members uh, of the local water governing districts, such as GMD2, were engaged in decision making using hydrologic models related to broader water management and policy. But none of the agricultural producers that we interviewed used models for decisions on their operations. However, decisions on irrigation are made within a regional water management framework that is in part informed by hydrologic models. Our mental models analysis revealed that epistemic value for accuracy most strongly influence water management decisions, particularly short-term operational decisions and long-term planning decisions. This was followed by nature value stewardship, which mostly informed decisions related to conservation. Uh, Although many of our participants expressed concern for accuracy, this does not mean or imply that developing more accurate models alone would increase the usability of these models. There needs to be balance between three important aspects of models: usability, reliability, and feasibility. In addition to accuracy, transparency was also highly valued by participants, which suggests that model developers can explain why they might have to sacrifice accuracy to privilege usability or applicability across a larger region. In Kansas, agricultural producers currently have fewer opportunities for involvement in the modeling process than state agency officers and staff. So, including agricultural producers and other stakeholders, such as municipalities, in the modeling process, could introduce new knowledge and ideas and can lead to greater ownership and social acceptance of decisions, which can ultimately improve water management and water conservation in the GMD2 and the broader Kansas region. Uh, that's all I have. I hope you enjoy my research and find it useful. Thank you so much.